Hello, I am Ms. Baudette's past self, and I'm going to teach you guys about gas laws. So first, I want you guys to do a couple of review problems. So here they are on the screen. For these problems, you're going to want a periodic table and a calculator. So here's a periodic table in case you want to pause the screen with the periodic table. Here's the problems again. And if you want to find a typed up copy of these, if you go to the PowerSchool page, you'll see under Unit 6 packet. If you click on that, these problems are just straight out of the packet. So we've got the introductory page, and then we've got these problems. So go ahead and pause the video and work on those problems, and then come back when you're done. Okay, so I'm going to assume that you have attempted these. So if you want to check your answers real quick. So here are the answers. So we should have 136 grams per gas, 145. Skip ahead to the part of the video where I'm talking about the ideal gas law. If you got any of those wrong, go ahead and keep watching, and I'll explain how to do those. All right, so let's start with the first one. So we want to find the molar mass of CaSO4. So what we need to do is we need to look up the molar masses of each of these on the periodic table. So we need to know the molar mass of calcium, molar mass of sulfur, and molar mass of oxygen. So let's go ahead and look those up real quick. Here is calcium, molar mass of 40. Remember, the molar mass is a number in the bottom, the bigger number, right? This 20 up here, that would be the number of protons. So calcium, molar mass of 40. Oxygen, molar mass of 16. Sulfur, molar mass of 32. I'm rounding them because I'm lazy. You don't have to round them, though. It is going to be more accurate if you don't round. But it's fine if you round them. It's, like I said, I'm just being lazy. Okay, so calcium's 40, oxygen 16, sulfur 32. Let's put those in. Calcium is 40, sulfur 16, oxygen 32. And then in this chemical formula, it says CaSO4. So we have 1 calcium, 1 sulfur, and 4 oxygens, right? So we can multiply each of these by 1 calcium, 1 sulfur, and there's 4 oxygens, so we'll need to multiply that by 4. Wait, just kidding, I mixed these up. Sulfur is 32 and oxygen 16. Yeah. All right. So 40 times 1, of course, is going to be 40. 32 times 1 is 32. And then 16 times 4 is 64. And then we just need to add these together to get the total weight, right? Because the total weight of CaSO4 should be the weight of our calciums plus our sulfurs plus our oxygens. So 40 plus 32 plus 64. 40 plus 32 plus 64 is 136. Okay, and then we need units for our answer for molar mass. So if you guys remember, we measure molar mass in grams per mole, right? So grams per mole. So I can say 136 grams per 1 mole. So what this means is if I have 136 grams of CaSO4, like I just weigh out that much on a balance, and that's how much CaSO4 I have, that means I would have 1 mole of CaSO4. So I would have 6.02 times 10 to the 23rd particles of CaSO4. Okay, so this is our molar mass. All right. So now we want to go and convert grams to moles. So in order to convert grams to moles, you need to know the molar mass. So the first thing we're going to do here is we're going to find the molar mass. So we have 30 grams of oxygen gas. We need to find out how many moles of O2 gas we have. And notice it says oxygen or O2 gas, right? Because remember, oxygen is diatomic. So if you were to find little oxygens in the air, right, they're going to go in pairs of 2, right? So this is what oxygen molecules would look like, which means that we're not going to use the molar mass of 1 oxygen. We need to use the molar mass of 2 oxygens. We need to multiply it by 2. So if I look up oxygen here is oxygen, right? So 1 oxygen would be 16 grams per mole. So 2 oxygens would be 32 grams per mole, right? So 2 oxygen atoms or 1 oxygen molecule. When a picture, it looks something like that, right? So there's 2 oxygens. Okay. And so we've determined that 1 atom is 16 grams per 1 mole. So then our molecule is going to be 32 grams per 1 mole. Okay, so this is our molar mass. So 32 grams of O2 per 1 mole of O2. Okay, and then we just need to convert this 30 grams that we're given in the problem, we need to convert it to moles. So I'm just going to write out 30 grams, and then I have 2 options here. So I can either multiply by this fraction of the molar mass, or I can multiply by this fraction flipped upside down. In this case, I'm going to want to flip it upside down because I need to make my units cancel. So 32 grams of O2 on the bottom, 1 mole of O2 on the top. Grams cancel, so 30 times 1, so that's going to be 30. So 30 divided by 32. And that gives me 0.9375. Thinking about our units, we can see here that because grams have canceled, we're left with moles, so our units must be moles. And the other thing is in the problem, you'll notice they asked how many moles. So this checks out. So this is our answer. Okay, so we've converted from grams to moles. So the next question is just practice going backwards, so moles to grams. So we have 5.2 moles of nitrogen gas. How many moles of N2 gas do we have? So again, we need to find the molar mass. You'll notice nitrogen is also diatomic, right? So it's N2. So if we were to draw a picture of it, it would look like this with 2 nitrogens. So we need to find the molar mass of nitrogen and then multiply by 2. Here is nitrogen. Molar mass is 14. So 14 grams per mole. So we'll do 14 times 2, which gives me 28. So 28 grams per 1 mole. And now I just need to use my molar mass, my number of moles, to figure out how many grams. That should say grams. Otherwise, this problem would be really easy. Luckily, by the time you guys finally see the packet in the future, I'm sure I will have actually fixed it. Okay. Right, so 5.2 moles, let's convert it to grams. So I'm going to start by writing out the number I'm given in the problem, 5.2 moles. And again, we have this fraction, right? So we have 28 grams over 1 mole. So I can either multiply by this fraction or multiply by this fraction upside down, whichever way it cancels. And it turns out I can just multiply by this fraction, right? So if I write 28 grams over 1 mole, moles cancel, and we get 5.2 times 28 divided by 1. 5.2 times 28, 145.6. So I get 145.6 moles of N2 gas. Okay. So there's that practice. And then we have converting between Celsius and Kelvin. So one of the easiest ways to do this is to just write down the equation. But let's say it's been a while and you've forgotten the equation, because that happens to me a lot, right? So the easiest thing to do for me to remember the equation is to think about absolute zero. So we know that 0 Kelvin equals negative 273 degrees Celsius, right? And the other thing that we know is there are no negative temperatures in Kelvin. Right? So that's a quick sanity check. If you're solving for the temperature in Kelvin, you're like, oh, it's negative 50 Kelvin or something. Like, that's definitely wrong. There are no negative temperatures in Kelvin because the absolute coldest temperature is 0 Kelvin. You can't go any colder. Okay, so that's another thing that can help you to remember this. Like, if you're like, oh, shoot, which one was Celsius, which one was Kelvin? Well, it's not negative 273 Kelvin. Like that does not exist. Okay, but let's convert between them. So let's see. So the first thing we did, so we have practice going from Celsius to Kelvin. So let's think about this. Degrees Celsius to Kelvin. If I look at this absolute zero thing here, how would I go from Celsius to Kelvin? So negative 273 turning into 0. Well, I would have to add 273, right? So add 273. So if I wanted to write that in a nice little formula, I could say you take the degrees Celsius, you add 273, and then you get your temperature in Kelvin. Right, so this is the equation that you guys probably have written down in your notes from earlier. Okay, so now that we've got this equation, we can figure this out. So the temperature outside is 10 degrees Celsius, converted to Kelvin. So I need to add 273, or in the form of this equation, I take my degrees Celsius plus 273, it spits out Kelvin. Right, so Celsius plus 273 equals Kelvin. 10 plus 273 equals Kelvin. Let's see, that's going to give me 283 Kelvin. Right, so there's my answer. Okay, and then the next thing we need to do is we need to go backwards. So again, if we think about this equation here, right, just the absolute zero equation, how would you go from Kelvin to Celsius? Well, to go from 0 to negative 273, you would have to subtract 273, right? So you can say Kelvin to degrees Celsius. We are going to subtract 273. Or if we want to write a fancy little algebraic equation here, you're going to take your temperature in Kelvin, subtract 273, and you get your temperature in Celsius. The other thing you could do, and you guys can check this algebraically, but these two equations are the same, right? So yeah, so like, for example, if you were to take this equation over here and you were to add 273 to both sides, then you would get back this equation on the right over here, right? So you could also just algebraically rearrange that equation, whichever way is easiest for you. Okay, so we've got this equation. So we've got 320 Kelvin. We need to convert to Celsius. And our equation is Kelvin minus 273 equals Celsius. So I can say 320 minus 273, and that will get me my temperature in Celsius. So 320 minus 273, and that gives me 47. It's going to be 47 degrees Celsius. Okay, so that's all of the practice ones, and then I'm going to move on to teaching you guys some new stuff. Okay, so let's learn about the ideal gas law. So this is new stuff. If you skipped forward, congratulations, this is where you should be. If you watched all the previous stuff, then you should be all reviewed and all ready to go and all ready to learn the ideal gas law. If any of you guys do have any questions on those previous problems and are still struggling with remembering how to convert between grams and moles or find molar mass, any of that, please let me know and I will work with you because you guys are going to need those skills in order to do these problems. All right, here we go. So the ideal gas law. Okay, so this is the ideal gas law. So PV equals nRT, or PIV-NRT, I suppose you could call it. And so just let me go through this equation and explain what each of these means. And as I go through this, go ahead and look in your notes. If you look in your packet, you will notice there's a spot to write down what each variable means. And I'm also going to go over 2 questions, practice problem 1 and 2, and you guys can take notes on them if you guys want. So that's also in your packet. All right. So P is our pressure in atmospheres. So atmospheres is, I don't know, it's kind of a nice unit for pressure. So it's 1 atmosphere is sort of the standard pressure you would feel if you're standing around outside. So if you think about it, you're standing around outside, there's 1 atmosphere of air pushing down on you. Like there's literally, you're on Earth. Earth has 1 atmosphere, right? So 1 atmosphere would be sort of like a normal pressure. If you're under like a lower pressure, you know, maybe it's only half an atmosphere or something. Maybe if you're under a high pressure, it would be like, I don't know, 2 or 3 atmospheres, something like that, right? So atmospheres is just our unit for pressure. And you can measure pressure in other units, but to keep things simple, let's just stick with atmospheres for now. Okay, so that's pressure. Then we've got volume. So V is volume in liters. And yes, you can measure volume in other units, but we're going to have to put it in liters. Because like I said in the corner here, units are important. So you guys are going to need to convert everything into these units. So for example, in a problem, if I give you a volume in milliliters, you'll have to convert it to liters. N is moles. So the conversion here would be, I suppose, if I gave you a mass in grams, you might have to convert to moles. But if I give you something in moles, then it's just moles. R is the ideal gas constant. So R is a constant. So whenever you're asked to find R, it's just 0.0821, like it's just this number. And here's where units come into play. So there are different values of R with different units. So because the value of R that we're using has these units liters times atmospheres over Kelvin times moles, those are the units we have to use. So that's why I say volume in liters, pressure in atmosphere, right? That's where they're coming from. There are other values of R with different units. So like if you wanted to use different units for pressure, you could use a different value of R, but we'll just keep things simple. And this is what R is. It's just 0.0821. Last we have T. So T is our temperature in Kelvin. And this is important. It has to be in Kelvin. No degrees Fahrenheit. First of all, Fahrenheit is hearsay. That's not scientific. That's what Americans use. So definitely no Fahrenheit, but not even Celsius. We need it in Kelvin. One of the reasons for this is, remember, there are no negative temperatures in Kelvin, right? So that means we're not going to be plugging in a negative number for the temperature, which is really handy because, for example, you know, let's say you plugged in a negative number for the temperature and you happen to get out like a negative volume. That wouldn't make any sense, right? So the fact that it's measured in Kelvin ensures that we're going to get out numbers that make sense out of this equation. Okay, so that's PV equals nRT. That's what each variable stands for. And so in these practice problems, essentially what you're going to do is you're going to use the equation PV equals nRT. You're going to plug things in. You'll always be solving for one variable, right? So remember, you know, let's say we knew pressure, volume. Let's say we didn't know moles. We know R, we know T, right? Then you can plug that all in and solve for moles. So in each of these cases, each of these problems, you're going to know all of the variables except for one, and you'll be solving for the last variable. The other thing to keep in mind is sometimes you will have to convert units, right? So remember, pressure in atmospheres, volume in liters, N is moles, R is 0.0821, and temperature in Kelvin. So if I give you any of these numbers in different units, you have to convert to these units in order for things to work. And this is also what the answers will come out in. So like, you know, let's say it spits out a pressure and you're like, huh, I wonder what units that's in. It's in atmospheres. If it spits out a volume, it'll spit it out in liters. If it spits out some number for N, that's moles. Spits out some temperature, that's in Kelvin, right? And so once you know what units it's in, you can convert, but keep that in mind that these are the units that we're going to use here. Okay, so I'm going to go ahead and do the first practice problem. All right. So a container holds 5 liters of oxygen gas. The gas is at a temperature of 300 Kelvin. There are 3.2 moles of oxygen gas in the container, what is the pressure in the container? Okay, so let's write out our equation. So I have PV equals nRT. And then let's start plugging these in. Let's see. So 5 liters of oxygen gas. So that's a volume. So 5 liters is going to go in for my volume. Temperature of 300 Kelvin. Okay, that's my temperature. There are 3.2 moles of oxygen gas. So that's N. That's 3.2. And what is the pressure in the container? So this means we are going to be finding the pressure. So we are solving for P. And then the last thing that's not given in here is we need R. So remember, R is 0.0821, right? Because it's just going to be this number. And if you use the units of liters, atmospheres, Kelvin, and moles, then you can just use this number for R and you're good to go. So R is going to be 0.0821. And let's double check our units. So we don't know pressure, but pressure should come out in atmospheres. Volume is in liters. Good. We have moles. That's good. R is good. And our temperature is in Kelvin. So that's good. So all the units check out. Then I just need to actually plug in these numbers. Right? So PV equals nRT. So P, I said, was a question mark. We don't know. V is 5 liters. Oops, there should be an equal sign there. N is 3.2 moles. R is 0.0821. And T is 300 Kelvin. Okay, so then we just need to solve for P. So let's see, P times 5 liters, so that would just be 5P, and then let's multiply all this stuff over here. So let's see. This is 3.2 times 0.0821 times 300. 78.816. 78.816. And then we need to get P by itself. So remember, we're multiplying P by 5. So the opposite of that is dividing by 5. So we're going to divide both sides by 5. So 78.816 divided by 5. 15.76. So P equals 15.76. Think about what units this should be in. So remember, we always measure pressure in atmospheres. So this is in atmospheres. Let's see, I'll write that in the middle. So 15.76 atmospheres. So that is my pressure. Okay, so that's the first practice problem. And let's do the second one. Okay, so again, PV equals nRT. And let's read this problem. So 250 grams of argon gas. So that might throw you guys off at first because you're like, well, there's no grams in this equation, right? But we can convert grams to moles. So that's what we're going to have to do. We're going to have to convert it to moles in order to plug it in. Let's see what else. Are held in a 6,300 milliliter container, right? Okay, so that's going to give me my volume, but we need it in liters. So we're going to have to convert it to liters. At a pressure of 1.2 atmospheres. Okay, that's fine. That's just my pressure. And then it says, what is the temperature of the gas in degrees Celsius? Okay, so we are finding the temperature. And also notice they asked for the temperature in degrees Celsius. So this equation will spit out an answer in Kelvin, right? Because that's the units that it uses. So we're going to have to convert, right? So we'll say equation spits out temp in Kelvin. We must convert to degrees Celsius. Okay, let's see. So I've got a lot of unit conversions here. So let's do all of our unit conversions and then we can start plugging in. So the first thing I've got here is I have this 250 grams of argon gas and I need to convert it to moles, right? So 250 grams of argon gas need to convert to moles. Okay, well, in order to do that, I need the molar mass of argon, which means I need to look it up on the periodic table. Argon is right here, molar mass 39.948. So we'll call that about 40. So we'll say 40 grams per 1 mole. Let's say that argon is 40 grams per 1 mole. Okay. So I have 250 grams. Let's see. So I've got this fraction. Do I need to flip it upside down? Yes. So 40 grams on the bottom, 1 mole on the top. Great. So my grams will cancel. So 250 times 1 divided by 40. So 250 divided by 40. 6.25. And then my unit is moles. So 6.25 moles of argon. Okay, so that's our first unit converted. Let's see, what else did we need to convert? So grams of argon gas, check, convert it to moles. Milliliters, we need to convert to liters. So let's do that. So 6,300 milliliters. So a couple ways you can convert this to liters. King Henry died by drinking chocolate milk. Let's see, here is milliliters, and then liters is our base unit. So we could go 1, 2, 3, 1, 2, 3. So you would get 6.3 liters. The other way you could do this is we know how many milliliters there are in a liter. So if you remember, there are 1,000 milliliters in 1 liter. Then you could just do 6,300 times 1 divided by 1,000, and that will get you the same answer. That will also get you 6.3 liters. So doesn't matter which way you guys do it, whichever you're most comfortable with. Okay, let's see. So volume converted, check. Pressure's already in atmospheres, that's good. And then we need to remember to convert this temperature at the end, but that won't happen until we plug things in. Okay, so I think we are ready to plug things into our equation. So PV equals nRT. So let's start with P. What is my pressure? It is 1.2 atmospheres. So let's plug that in. 1.2 atmospheres. Then I need V, my volume. Well, remember we converted that to liters, right? So that was 6.3 liters. N, moles, right? So they gave us 250 grams. We converted it to moles, and that was 6.25 moles. R is the ideal gas constant, so that is 0.0821. So remember, that's a constant. You can just always plug that in, so long as you're using the right units. And then T, T is temperature. And so it says, what is the temperature of the gas in degrees Celsius? So we are solving for T. We do not know T. Okay, so let's solve this equation. let's see. So on the left here, I have 1.2 times 6.3. 1.2 times 6.3, 7.56. And then on the right, 6.25 times 0.0821 times t. So let's do 6.25 times 0.0821. So that gives me 0.513 times t. All right, so then we need to get t by itself, right? So we're multiplying it by 0.513. So we need to do the opposite. So we need to divide by 0.513. So 7.56 divided by 0.513. 7.56 divided by 0.513. And that gets me 14.74. 14.74. That is T. Might be a little bit different depending on rounding, but close enough. Okay, and then let's think about what units this is in. Right, so we use PV equals nRT. If you guys remember back from before, we measure temperature in Kelvin. So this number that it spit out is going to be in Kelvin. So it's going to be 14.74 Kelvin. And yes, that is super cold. I made up random numbers for these problems, so that's why we got a really cold temperature. Okay, but the question says, what is the temperature of the gas in degrees Celsius? So we need to convert this to Celsius. So convert to degrees Celsius. If we go back to earlier, let's see, how did we go to Celsius? Here we go. Right, so Kelvin to Celsius. So we said if you're going Kelvin to Celsius, we need to subtract 273. Kelvin to degrees Celsius, subtract 273. 14.74 minus 273. And let's see what that is. 14.74 minus 273 equals. So that gives me negative 258.26. And this is degrees Celsius. Okay, so that should be your answer. All right, so that's all the practice problems. So what I want you guys to do, so for homework, so pages 1 through 3 in the packet, so you should already be done with the first 2 pages. We just did them, right? First page was the practice, the review problems. Second page was these ideal gas law problems. Third page is what's your real homework, the new stuff. So it's a bunch more ideal gas law problems, 5 of them. So go ahead and do that for homework. And then we'll go ahead and whiteboard them next class. All right. That's all for now. I will see you guys later. If you finish watching this video and I haven't met with you yet, please stay in the Zoom call until I meet with you. And other than that, I will see you guys later. So bye.